In this course, we will see the principles of spanning tree by VLAN. In this diagram, we can see that all the switches A, B, and C are part of VLAN 10, and VLAN 20 is only configured on switches A and B. In your opinion, is there a loop in VLAN 10 and another in VLAN 20? The answer is no for VLAN 20 because there is only one link between switch A and B, so there is no loop. On the other hand, there is one for VLAN 10 because there are 3 switches in this VLAN. We will see how the spanning tree will manage this topology made up of several VLAN, and which ports it will decide to block, and why. The switch will use a spanning tree by VLAN. For each VLAN, we can have a different root bridge if we want, as shown in the diagram just displayed. On this topology, we have 2 VLAN, VLAN 10 and VLAN 20, and each of them has elected its own switch for the root bridge. The VLAN 10 took switch A, and the VLAN 20 chose switch B. As you can see, each of the VLANs also has its own blocked port to avoid loops. This configuration is ideal for redundancy because if we would only have one root bridge for the 2 VLANs, that would mean that there would be only one port to block, and therefore a link that will never be used. We just saw the spanning tree by VLAN. In the previous chapter, we saw a classic spanning tree. There is also a much faster spanning tree for each of them, rapid spanning tree, and spanning tree by VLAN. The calculation of the spanning tree is too slow nowadays. That is why there is a faster version, in order to improve the speed of convergence. We will not go into details for the moment, because it is not in the CCNA program. Rather, it is part of the CCNP switch program. You just have to know that the difference is only in the speed. The last type of spanning tree to see is the multiple spanning tree. We have seen that it is possible to calculate a spanning tree by VLAN, and our example had 2 VLAN. But what if we had more than 500 VLAN, as shown in the diagram just displayed? Here, VLANs 1 to 250 have been configured on all switches, and VLANs 251 to 500 are configured only on switches A and B. Is it really useful to do a spanning tree calculation for each VLAN? This would represent 500 spanning tree calculations, which would overload the switch unnecessarily. This is where multiple spanning trees come in. Thanks to it, it is possible to assign VLAN numbers to a spanning tree instance. If we use it on this topology, we would therefore have one calculation for VLANs from 1 to 250, and another calculation for VLANs from 251 to 500, which represents only 2 calculations, which is much better than 500. Once again, there is no need to go into detail about this type of spanning tree because it is not on the CCNA's program either. You will only see it if you continue to the CCNP switch.